Hey everybody, welcome back to Algebra 2. We're starting Unit 7, Sequences and Series. Lesson number 1 is going to be about sequences. You should know what a sequence is. You've actually done these for quite a long time, right? You've counted by fives before, right? 5, 10, 15, 20. That's just a specific set of numbers in a specific order, and that's what a sequence is, right? It's just a list of numbers in a specific order. Now, I did a very specific one where I was counting by fives. But we could also do other types, right? There's multiple types of sequences. We have arithmetic and geometric to start. So let's look at arithmetic sequences. An arithmetic sequence is when the difference between each consecutive term is the same. When I told you that we were counting by fives, the difference between each of those numbers, 5, 10, 15, 20, they were always 5. We call that the common difference. So arithmetic sequences have a common difference between every single term. So what we're going to do, basically, we're going to be either adding or subtracting the same value each time. That's why this word right here, difference, is very important, because all we have to do is do a little bit of subtraction to make sure that we have a common difference. And that's what we're going to do in these couple of problems right here. Right? They say find the common difference for each of these sequences. So it's going to be pretty simple. You can actually use a calculator for this if you're careful to type it in. I don't need to see you do this by hand. But what you're going to do is you're going to start at the end and you're going to start subtracting going backwards. So I'm going to start with 64 and I'm going to subtract 52. So 64 minus 52 is 12. And then I'm going to do from 52 to 40 to make sure that I have that same amount in between. So 52 minus 40, that's also 12. And I'm going to have to make sure that it's true all the way through. So I'm going to do 40 minus 28. That also gives me 12. So seeing as I had 12 between each number, that would be the common difference for this sequence. So we can abbreviate it to CD equals 12. This problem right here, we'll start with -1, then we'll subtract +1. Right, so I'm starting at the end and going backwards. That gives us -2. Now I'll start with 1, subtract 3. Again, we get -2. And finally, 3 minus 5 gives -2 again. So in between each of these numbers, we ended up having -2. So the common difference in this particular sequence is -2. Last one here, 19 going back to 15. So again, difference, we're going to subtract. That gives us 4. Then we'll go from 15 to 13. And that gives us 2. Hey, wait a second. They have to be the same amount every time, right? Especially if I look from 10 to 13, that's a difference of 3. So I'm getting all different numbers when we look at the spacing between, the difference between them, not the same. So this is not arithmetic. By the way, I call this arithmetic. I hear a lot of people say arithmetic. I know it's spelled the same way, but I think depending on how you say it, it means just a slightly different thing. I could be wrong about that, but I'm going to be calling it arithmetic just because that's what I've always been taught. So anyways, you've got a couple of these to try out. If you'd like to pause the video, try them out, and then resume when you're ready to check. Alright, so let's see how you did here. Hopefully you did all 3 of these, because I'm going to go over all 3 right now. So you're going to start at 9, you're going to subtract 4, you'll get a number here, 5. We're going to do that again. 4 minus -1, double negatives is going to give me 5. And then lastly, from -1 to -6, again, double negative, 5. So our common difference here is 5. Okay, from 7 to 8, well, that's -1. And from 8 to 13, well, that's -5. So right away I can already see that there's a big problem here. These two numbers don't match. This is not arithmetic. I would have also been okay if he said not possible, but we should be saying not arithmetic in this instance, because if there's a common difference, it would be arithmetic. If it doesn't have one, it's because it's not arithmetic. That's why we're writing it that way. All right, this last one, again, you could have used a calculator, would have been fine with me. I'm probably going to be doing that right now just to make this faster for everyone who's watching this video. So let's see. 167 minus 249. That's negative 82. 249 minus 331. Oop, got negative 82 again. And then finally 331 minus 413. We would have also gotten negative 82. Let's write that down real quick. So you got a common difference here of negative 82. Okay, so as you can see, it doesn't matter where we start with these numbers, right? These ones are starting negative 6. These ones are starting at 413. They have all sorts of different common differences here. All that means is that we have different options for our series, or our sequences, rather. All right, so here we have some more of the same types of problems, but these are just a little bit more difficult because of those fractions, right? As I would probably say in class, here come the fractions, Jeremy. So we're doing the same thing. We're going to start with 7 over 3. We'll subtract 5 over 3. Because these have the same denominator, we can do that real quick. That's going to leave us with 2 over 3. We'll do that from 5 over 3 to 1. Now, 1, let's see if I can do this off to the side here. 1 is really over 1. And if I want to do this subtraction, I need that 1 to really be a 3. So we're going to have to multiply this whole thing by 3 over 3. So 1 times 3 would give us 3 over 3. So that right here, that 1 is really 3 over 3. All right, so 5 minus 3 is 2. So far our common difference seems to be matching. Now I already converted this just a second ago, so I know it's going to be 3 over 3 minus 1 over 3. That also gives us 2/3. So we had 2/3 difference between each of these. It is arithmetic. Your common difference is 2/3. All right. Let's see, negative 3 minus 7 over 4. Well, let's see, this has to be a 4 here. Right, but right now, really, it's over 1. So I got to multiply both of these by 4. So that's going to be negative 12 over 4 minus negative 7 over 4. That becomes addition. Negative 12 plus 7 would be negative 5. So that's our first common difference. Alright, so let's see, now we're doing negative 7 over 4 minus, let's see, 1/2. That 2 needs to be a 4, so we're going to have to multiply by 2 over 2. That's going to be minus 2 over 4, right? Multiply. Again, that becomes addition. Negative 7 plus 2 is negative 5 over 4. So we got negative 5 over 4 twice. And again, I already converted this, so it has a 4 on bottom. So it was negative 2 over 4 here. Same number. Now we're going to subtract 3 over 4. Remember, this one's positive, so we don't have that double negative situation. That's going to give us negative 5 over 4 again. So our common difference, negative 5 over 4. That was a little tricky because we had to change the denominators quite a few times. But hopefully you're starting to get used to doing that. That's probably the most difficult part about these problems would be when you face the fractions, right? Because you have to have the same denominator. So if you need to rewind that and watch those again, go for it. If not, you have a couple of problems right here. Oh no, I'm sorry, these aren't you tries. Let's do them right now. My bad. So let's see. It says find the common difference and write the next 3 terms. All right. Oh, I see what I did. Anyways, I guess this was the you try, so I guess I did that without you. Alright, so here we go. Find the common difference and write the next three terms. So let's see, 27 minus 21 is 6. 21 minus 15 is 6. So our common difference here is 6. So basically we're adding 6 each time. So let's see, 27 plus 6 would be 33. Plus another 6 would be 39 and 45. Okay, so I just took my last term, figured out what the common difference was, and just continued to add it each time. Ooh, this one's got fractions, but luckily we have the same denominator. So let's see, 8 over 5 minus 4 over 5 is 3 over 5. That should be the same here. And it is. So we have a common difference of 3 over 5. So that's what we're going to add here. So remember, our denominators aren't going to change. Those will stay as 5s. But 8 plus 3 is 11 over 5. If I add another 3, that would become 14 over 5. And finally, add another 3 will become 17 over 5. So those are the next three terms in that sequence. Okay, so you got a couple to try out here. Okay, you're going to find the common difference and then write the next three terms. Again, you can use a calculator if you need to. Pause the video and resume it when you're ready to check all three. Alright, let's try this one out here. So let's see, 51 minus 68 is going to give us negative 17. 68 minus 85 also negative 17, so that's our common difference. So here we're subtracting 17. I hope that that's what you were doing, because you should be noticing it going down here. So 51 minus 17, we get 34. Ooh, 17, and then 0. All right. The next problem, we've got 3, which is really over 1. And these are both 3's here, so I need to multiply this by 3 over 3. That's going to be 9 over 3. So that's what this term is, 9 over 3. So let's see. 9 over 3 minus 5 over 3 is 4 over 3. Now let's just check one more here. 5 over 3 minus 1 over 3 is 4 over 3 again. So we got 4 over 3 both times. That's our common difference. That's what we're going to be, because it's positive, we'll be adding 4 over 3. So 9 plus 4 is 13 over 3. 13 plus 4 is 17 over 3. 4 plus 17 is 21. But 21 divided by 3 is 7. So hopefully you reduced that. I will be looking for you to reduce these if you can, which something like this you can reduce. And finally, the last one here. Let's see, 19 minus 21 is negative 2. 21 minus 23 is also negative 2. So we're subtracting 2 each time. So 19 minus 2, 17, minus another 2, 15, and minus another 2, 13. So those were arithmetic sequences, right? We added or technically subtracted sometimes, but I've told you those are the same things at this point, and hopefully now you're starting to see that adding, subtracting, it's the same thing. It still gets us the sequences that we're looking for. But we also have geometric sequences to look at. So, a geometric sequence is when the ratio between every consecutive term is the same. So last time we saw the word difference, which meant subtraction. Ratio means fraction, right? They should have the same fraction between each of them. And how we're going to do that is we're going to take one number, the last number, and divide it by the number before it. Same way that we did with the subtraction. Start at the end, work your way backwards. Okay, it's also called the common ratio. So you have a couple problems here that say find the common ratio for each sequence and write the next two terms. So basically what we were just doing at the top. But this time we're using some division. And again, use your calculator if you need to. I'm going to take 108 and divide it by 36. And I got 3. Then I'm going to check between 36 and 12. So 36 divided by 12. Also 3. And I continue backwards. 12 divided by 4. It's also 3. So when I divided each of these terms, it seems that I was multiplying by 3 every time. So if I want the next two terms, I'm going to be multiplying by 3. So 108 times 3, we get 324 times 3 again, 972, and then times 3 again, 2,916. Okay, so pretty simple process. You take your last number divided by the previous number, make sure you get the same common ratio, right? It should be the same number every time. And if we get the same number every time, that's what we're going to be doing. We're going to be multiplying by that amount. So 108 times 3 again, times 3 again. Pretty easy to do. If you have one of the school calculators, which fortunately not too many of you were able to grab before you left, but there's ways of changing decimals into fractions if you have that calculator. So that could be a handy thing for you to use if you have that ability. So let's take a look at this next problem. This time we have 2,808. 2808 divided by the number prior, 16,848. Alright, so I'm going to do that on this calculator. Right? 2808 divided by 16,848. It gave us a decimal, right? And this is what I was saying. Not really a big fan of the decimals. I want to know what that is a fraction. So if I click on math on the calculator, the first option that comes up is frac. So press enter, enter, and look at that. It converts that into a fraction for us. 1/6. So we can continue to do that same thing. Right? I'm just going to do this on the calculator. So I'm going to do 16,484 divided by 101,088. So I'm doing this on the calculator. Math, frac, enter, and ooh, I'm getting a completely, oh, that's because I'm doing the right numbers. Let's try that again. Yeah, this time if I do it correctly, yeah, I get 1/6 again. So from here to here was 1/6. From here to here, 1/6. So I gotta just check this one last one. 101,088 divided by 606,528. Okay, so again, I'm just typing in the last couple of numbers divided, hitting enter, and I'll press math, frac, and it comes up as 1/6 again. So we have the same multiplier of 1/6. So I'm going to take my last number, multiply by 1/6. 2808 times, and if you write it just as the fraction itself, the calculator knows exactly what it's doing. You could technically divide by 6, but why not just work with what you've been using? It's a little bit easier. So the first number we get is going to be 468. We only wanted 2 terms. I guess we did too many here. Let's see, 468 times 1/6, 78. So I wanted 2 terms. Last time we did 3, no big deal. But those are the next 2 terms. Okay, so we use the calculator for a good amount of that. No big deal, right? If we start with this last one, right, I'm going to type in exactly what I see on the page into the calculator. Alright, so let's see here. Clean this out. Not good lighting over here, huh? Alright, so I'm going to start with 4/27 Notice I'm using parentheses. I'm going to do divided by a new set of parentheses, 2 over 9. And it gave me a decimal, math, frac, enter, 2/3. So again, a lot of calculator work for this. But from here to here, 2/3. Now I'll repeat. Okay, I'm going to do 2 over 9 divided by, this one is 1/3. 1 divided by 3. Gave me the same decimal, so it must be 2/3 as well. So from here to here, oops, 2/3. And then finally, 1/3 divided by 1/2. 1/3 divided by 1/2. Oops, again, the lighting's a little poor there, but got the same decimal, so it must be the same fraction, 2/3. So I'm multiplying 4 over 27 by 2/3. That's what we're doing here. So again, I'm going to be doing this on the calculator. So I'm starting with 4 over 27 divided by 2/3, we said was our common ratio. It gives us a decimal, but I want a fraction. Comes out to 2 over 9. 2 over 9. And I'm going to now do the same thing, right? Fraction 2 over 9 times, I'm sorry, divided by 2 over 3. And we get 0.33. So let's see. Math, frac, enter, 1/3. Oh, I know what I'm doing wrong. We need to multiply. I'm dividing. 4 over 27 times 2 over 3. My mistake. So these are not I was continuing to go this way. We want to multiply. We want to go that way. So 4 times 2 would be 8. 27 times 3 would be 81. So we get 8 over 81. My mistake, guys. And then again times 2. So that would be 16 over, let's see, 81 times 3 is 243. My mistake. I was going that way. I'm like, I don't know why we're getting the same numbers as before. Right? We want to go this way. So, one last one. Hopefully I won't make that same mistake again here. We're going to do 630 divided by 126. So from here to here we got 5. 126 divided by 42. Ooh, from here to here we got 3. So we're not multiplying by the same amount. 42 divided by 14. Yeah, so we got different numbers, right? This time we multiplied by 5, so this is not geometric. All right. So you've got a couple to try out on your own. Remember the process. I know I made a slight mistake earlier, but you start here, you divide by the previous number. If you get the same common ratio, you multiply by that amount going this way. I had accidentally divided earlier. You multiply. All right, so I want you to pause the video, try these 4 out, and resume when you're ready to check those 4. All right, so if I do 594 divided by 198, we get 3 from here to here. So that's our first common difference. 198 divided by 66 also gives us 3. 66 divided by 22 also gives us 3. So between each of these, we were multiplying by 3. So I need to multiply by 3 to get the next 2 terms. So 594 times 3, 1,782. Then we're going to multiply that times 3, 5,346. Okay, these ones, again, you can use a calculator for them, I'm going to type in exactly how I see it, including parentheses. So 3 divided by 40, close it, divided by new parentheses, 3 over 20. And that gave me 0.5, which I know is 1/2. Okay, so from here to here was 1/2. Now let's just keep on doing that and make sure that we get the same thing. All right. Actually, this one's easy enough that I can kind of see it. Right. If I multiply 10 times 2, that will get me that 20, and 1 times 3. So I can see that this is going to be 1/2 between each of these. And the same thing here, right? 5 times 2 would have given me the 10. So I can see it. Could I do it on the calculator? Absolutely. Not really necessary, though. So we're going to be multiplying by 1/2 going this way. So 3 times 1 stays as 3. 40 times 2 is 80. That's our first. The second one, 1 times 3 keeps it 3 again. 2 times 80 is 160. So far, hopefully you're getting those numbers. All right, let's try this last couple. 2,352 divided by 294. From here to here, I got 8. 294 divided by 42. Ooh, from here to here, I got 7. So we don't have a common ratio. This is not geometric. And the last one, let's see, 96 divided by 384. 0.25, so that's 1/4. 384 divided by 1536. Again, 0.25, so 1/4. And let's just check this one last one. 0.25 again. So our common ratio, 1/4 every time, so I'm multiplying by 1/4. So I'm going to do exactly that on the calculator. You could do times 0.25, or you could do divided by 4. I'm just going to do exactly what I see, 96 times 1/4. So that gave me 24 for my first term. And 6 for the second. Whew, this is a long video, 27 minutes, almost done though. Last couple of questions. We want to determine last couple of ones if a sequence is arithmetic, geometric, or possibly neither. So guess what you're going to do here? You're going to start by seeing if I do subtraction, do I get the same number? If that doesn't work, then I'll check division, see if I get the same number. And if not, then it's neither. Now some of these we can actually do pretty quickly by looking at them. Right? Like if I notice that I'm going up by a crazy amount every time, it's probably not arithmetic. So this looks pretty consistent. So let's try testing arithmetic. 14 minus 26 is negative 12. Now we'll go 26 minus 38. Also negative 12. So we just ruled out geometric because we didn't do any division and we're getting the same number. (38 minus 52). Ooh, but here we get negative 14. So did we use the same number every time? No. So it's not arithmetic. I don't think geometric's going to work, but let's just try it just in case. 14 divided by 26. I got 7/13. 26 divided by 38. 13/19. So it's definitely not working for geometric, so this is going to be neither. Right, we tried arithmetic, didn't work. We tried doing division, got 2 different ratios. It's got to be neither. Right, so we're going to just do the same thing. We'll start at 5 minus 8/5. 11/5 minus 8/5. That's 3/5. That was easy to do. This is going to be 5 over 5, right, because it's 1. So 8 over 5 minus 5 over 5. 3 over 5 came up again. Let's check that one last one. 3 over 5. I'm sorry, 5 over 5 rather, minus 2 over 5 is 3 over 5. So we have a common difference of 3 over 5. That's arithmetic. And the last one, well, I can see that these are getting increasingly larger, so it's definitely not arithmetic. Added 2, added 4, and so that didn't work. So let's check geometric. 16 divided by negative 8 is negative 2. Negative 8 divided by 4, negative 2. 4 divided by negative 2, negative 2. So it's the same ratio each time was negative 2, so this is geometric. So you have 3 to try out on your own. Pause the video and resume when you're ready to check. Alright, so let's try these out. If we were to try 9 over 32 minus 3 over 8, we end up getting negative 3 over 32. I doubt that's going to be the same between these two. So let's just try it. 3 over 8 minus 1/2. Yeah, definitely not the same thing. All right, negative 1/8. So these do not have the same common difference, so it's not arithmetic. All right, so let's try doing division. 9 over 32 divided by 3 over 8. And it's coming up with 3 over 4. So far our ratio is 3 over 4. Let's check the next one. 3 over 8 divided by 1/2. Yeah, it looks like that's going to work for us. Let's just make sure it works for the last one. 1/2 divided by 2 over 3. 3/4. So arithmetic didn't work. Geometric, we got 3/4 each time. Hopefully you came up with geometric for that one. Alright, I'm not seeing anything that looks like it's going up in crazy amounts. So let's just try doing arithmetic to start. 1270 minus 1052. Nope. Minus. I got 218. 1052 minus 834. 218 again. Oops. 834 minus 616. So in between each of these numbers, we got 218. That's a common difference. That means it's arithmetic. And finally, last problem. Last one to check. 336 minus 48. 288. Okay, well that's definitely not the difference between those two, so it's not going to be arithmetic. Let's try geometric. 336 divided by 48. I got 7 as a ratio here. 48 divided by 12 is only 4. So no common difference, no common ratio. Neither. Alright. That's the lesson, 34 minutes long. You're all done. If you want to write any questions down, write them down on YouTube, or you can bring them to class, or bring them to the internet, I guess. I'm not sure how that's going to work, but whatever you got to do, ask the questions. It was a long video, but really was not difficult. We did a lot of repeated work for this particular lesson. So I'll see you at the next one. It's going to be a little more exciting. See you then.